How's it going, everyone? Welcome. Elvira Gonzalez here. So let's continue our exploration on the Typescript handbook as a way to finally understand now first what this Typescript is all about and how to read this particular doc, right? So it all starts with the get started here. Let me see if I can pull this up here, particularly on the docs. And here, yes, about the Typescript handbook. So in order to understand this from the Typescript author's perspective, right? I'm going to start it from the get started, okay? Read about this briefly, and then starting to dig into the handbooks, how to read this, and also the reference, right? So to describe this as a high level, So on the get started, it says, hey, if you are new to Typescript or as a JavaScript programmer, it is good for you to understand is the different flavors of JavaScript. So first understanding is what JavaScript is, what JavaScript is allowed to, and what is a TypeScript or a static type checker, right? So yeah, so in my case, since I'm quite familiar with this, even though I won't skip this section because that's something that can give me is perhaps some of the basic insights that I might lose here, for example. And then I go into on the Typescript for JavaScript programmers and so on and so forth, right? So it says that congratulations on choosing Typescript as one of your first language. You're already making a good decision. So you probably already heard that the Typescript is a flavor or a variant of TypeScript, of JavaScript. The relationship between TypeScript and JavaScript is rather unique among modern programming languages. So learning about this relationship will help you to understand how TypeScript adds to JavaScript. So what is JavaScript? A brief history. So JavaScript, also known as ECMAScript, started in its life as a simple scripting language for browsers, right? At the time it was invented, it was expected to be used for short snippet of code embedded in web page. Here it is, code embedded in web page. At the end of the day, anytime that you read the word embedded, it's because there is now an application that allows you to run that script, right? In our case, the browser. So writing more than a few dozen lines of code will have been somewhat unusual. Due to this, early web browsers execute such code pretty slow. And remember, those browsers that are reading in C or C# or C++, right? They execute this scripting language, pretty slowly. And over time, through JavaScript become more and more popular, and web developers started using it to create interactive experience. Again, there is a hidden thing here that they don't mention, which is a lot of the VC they find very useful to write applications here in these browsers because now they can reach more broader audience. Okay, so it all starts, for example, with companies like pet.com, right? Sorry, is it this? Really? So it started with companies like Petcom, Petco, this one, right? Which, despite that it was founded in 1965, and then he jumped straight forward to the internet stuff in the early 2000s, it was too early for that company to say, hey, we're making some revenue here, right? So they suffer a lot in terms of revenue by being too early in the development. But in any case, after that, right, I also there are also other companies in that moment where they want to well, find new customers in on the internet, right? So because of that, that is when JavaScript became popular because it becomes economically interesting here. And the reason for me to actually look at this language like JavaScript or Typescript, right? So web browser developers respond to this increased JavaScript usage by optimizing their execution engines. Those web browsers developers, right, which is dynamic compilation. So JavaScript doesn't behave in that sense. It's more like a two-phase language. When it has the first language, which is run an static analysis, and the second language, or the second phase, is the execution of the code. This is one of the reasons why JavaScript, when you get asked for questions like, is JavaScript an interpreted or a compiled language? You know, this kind of questions that is asked a lot on job interviews. But it's because it's to know if you truly know what this engines works behind the scenes. You understand now all of this story of how do we get here and why now JavaScript that initially becomes as an interpreted language do all of this economically interesting and VC push and interesting among the shareholders. It's say, oh, okay, so now the research and development team, they say, well, it is important as a product to develop this kind of applications where we can now is not only push the boundary of what this application can do, the browsers, but also is to serve this content and to provide unique experience here. So, in extending what could be done, adding APIs, which in turn made web developers use even it more. On modern websites, your browser is frequently running applications that span hundreds of thousands of lines of code. This is a long and gradual growth of the web, starting as a simple network of a static page and evolving into a platform for rich applications of all kind. This is when you have things like web internet or accessible rich internet applications or area, right? One of the principles that's the people that oversee all of these standards on the web, known as the WV3C consortium, stand upon those principles. Is, hey, we want to make the web accessible, international. So internationalization and localization to provide now experience tailored to those cultures, and also privacy and security. So yes, so more than this, JavaScript has become popular enough to be used outside the context of browsers, such as implementing JavaScript servers using Node.js. The run anywhere nature of JavaScript makes it an attractive choice for cross-platform development. Why? Because at the end of the day, as long as you have something that can run JavaScript, in the case of the servers, a runtime, or in the case of the browsers, which is a runtime, but in this case is the browser, right? This is what you have here, right? And there are many developers at this day that use only JavaScript to program their entire stack. So there is, and I don't want to take too much. I want to make a quick tangent here, because most of the time, the way of how you, or traditionally the way how you write web servers or these internet applications was that you have a server and you have a client, The client was used heavily HTML, CSS, and JavaScript, as well as well, the web APIs that it provides. And on the server, you have now this PHP stuff or Ruby, right? Programming language that run on the server. In other words, you have to install that programming language, and those will be those language will have access to the underlying OS features. The OS at the end of the day is just a hypervisor that you can think of it like that, which offer you is functions that allow you to call system functions or system call, whether it is the CPU or the memory or the network, or input and output devices like camera, keyboards, mouse, speakers, and so now with that, right? So this has become useful because you just only have to know one language to execute all of these programs here. Okay. So yeah, to summarize, we have a language that was designed for quick uses and then grew to a full-fledged tool to write applications with millions of lines. Every language has its own quirk, oddities, and surprises. Then JavaScript, Humble's beginning, Humble's beginning, make it have many of the some examples. So for example, the equality, the triple equality, or the comparison here. Okay, because the comparison here now it has this thing called type coercion, right? JavaScript also accessing properties which are in presence, right? So which allow you to do this. And not to mention is the other is the null, right? So most programming language will throw an error when this sort of errors occur. Some will do so during compilation before any code is running. So when writing small programs, such queries are annoying but manageable. When writing applications with hundreds of thousands of lines of codes and serving that to hundreds of thousands of users, these content surprises are serious problems. So this we have now a Typescript, a static type checker language. So Typescript checks a program for errors before execution, and thus based on the kind of value, making it is a static type checker. For example, the last example above has an error because of the type object. Here is a Typescript error that you can find. So a type is a superset of JavaScript, right? So this is your syntax. Typescript is a language that is superset of JavaScript, like this. Typescript doesn't consider any JavaScript code to be an error because of its syntax. This means that you can take any working JavaScript code and put it into Typescript file without worrying about how exactly it is written. And more about the types. However, Typescript is a type superset, meaning that it's adding rules. The thing here, it adds rule about how different kind of values can be used. And different kind of values is, well, primitive and objects. And the early errors about object types was not to syntax error. It is an error of using some kind of value, a type, in an incorrect way. As another example, this is JavaScript code that you can run in your browser and it will log a value here, right? Because at the end of the day, it's doing coercion here. What is the value of this? That is a mind-bending stuff in JavaScript. Do this operator, right? Because arithmetic operators transform that into numeric operations. If one of the operator is a num, the other will be coerced to a num. So in this case, this will coerce that to a 0 if I write, because you may wonder, it's like, how do you know this? Well, because when you transform now an array into a number, especially an empty array, it will give you now as a very queer things to do. So if you try to do this, right, it will try to say infinite, which means that it's like you're trying to coerce that to 0, right? You may wonder, how do I know that this is something that will happen? Well, because in the case of numbers, for objects, it's going to transform that into a number. For array, it's going to transform this into a 0. But this is not true, for example, for map, which is going to transform into a nan, right? Which is now an object. Or even for functions, right? You define now a functions here, right? So you have to live with that. So this syntactically legal programs logs infinites, because at the end of the day, this specific value, JavaScript coerces that into a 0. Again, it's because this operation, arithmetic operations, is going to look at one of the operand, and if one of them is a number, it's going to coerce the other into a number, right? So this is why you get this infinite value here. So TypeScript does consideration division of number by an array to be a nonsensical operation, and we will use it an error. The right hand side of an arithmetic operations must be of type any, number, big N, or an enum type, right? It is possible you really did intend to divide a number by an array. Perhaps you just to see what happened, but most of the time, this is a programming mistake. TypeScript type checker is designed to allow correct programs through while still catching many common errors as possible. So not only in terms of the types, all right, what is the possible value that this can be, okay? And also define the rules of this possible value that this can be. But it also wants to determine is the runtime behaviors. So TypeScript is also a programming language that preserves the runtime behavior of JavaScript. For example, dividing by 0 in JavaScript produces infinite. Instead of throwing a runtime exceptions, as a principle, TypeScript never changed the runtime behavior of your code. This means that if you move code from JavaScript to TypeScript, it is guaranteed to run the same way, even if TypeScript thinks that the code has type errors. Keeping the same runtime behavior as JavaScript is fundamental promise of TypeScript, because it means you can easily transition between the two languages without worrying about subtle differences that might make your program stop working. And again, two things here. So TypeScript at the end of the day wants to impose rules to the kind of value that it can be possible, as well as the runtime behaviors of JavaScript, right? This is what you have now, this additional rules, or this superset, and it makes a lot of sense. The other is erase types. Roughly speaking, once TypeScript compiler is done with checking your code, it erases the types to produce the resulting compiled code. This means that once your code is compiled, the resulting plain JavaScript code has no type information. It's just plain JavaScript. This also means that TypeScript never changes the behavior of your program based on the type it infers. The bottom line is that while you might see type errors running compilation, the type system itself has no bearing on how your programs work when it runs. Finally, TypeScript doesn't provide any additional runtime libraries. Your program will use the same standard libraries or external library as a JavaScript program, so there is no additional TypeScript specific framework to learn. Learning JavaScript and TypeScript. We frequently see the question, should I learn JavaScript or TypeScript? The answer is that you can learn TypeScript without learning JavaScript. And TypeScript shares syntax and runtime behaviors with JavaScript, so anything you learn about JavaScript is helping you to learn TypeScript at the same time. Remember that at the end of the day here, based on the getting started, is TypeScript is adding these additional rules to describe how this value can be, or the possible type of these values, as well as runtime's behaviors in JavaScript, right? And once that is done, it won't interfere on the JavaScript output. In other words, your JavaScript code is going to, once you compile that, it's going to work in any browser. So TypeScript doesn't change the runtime behavior. So there are many resources available for programmers to learn JavaScript, and you should not ignore this research. If you're writing TypeScript, for example, there are about 20 times more Stack Overflow questions that JavaScript than TypeScript. But all of the JavaScript questions so applies to TypeScript. If you find yourself searching for something like how to sort a list in TypeScript, remember, TypeScript is in JavaScript runtime. JavaScript is JavaScript runtimes with a compiler time type checker, right? That's what it is, which makes sense, vastly sense. And well, what is the next resource that you want to go and to explore is that. So Microsoft JavaScript resource, JavaScript guide for Mozilla Webs, continue TypeScript for JavaScript programmer, and read the handbook and explore is the playground. So that's good. So now I'm going to read about the TypeScript for JavaScript programmer, which is what I want in my particular case. So you can now inference type, okay? And let's go to read this very quickly. TypeScript stands in an unusual relationship to JavaScript. TypeScript offers all JavaScript features and an additional layer on top of this, TypeScript type systems. For example, JavaScript provides language primitive like string and number, but it doesn't check that you consistently assign this. TypeScript does. This means that your existing working JavaScript code is also TypeScript code. The main benefit of TypeScript is that it can highlight unexpected behavior in your code, lowering the chance of bugs. This tutorial provides a brief overview of TypeScript, focusing on the type system. And this is the notions that for JavaScript programmers, TypeScript comes here. This type system, which infers the type based on the statement that you define in JavaScript, all right? If you read more about this, by understanding how JavaScript works, TypeScript can build a type system that accepts JavaScript code, but has types. This offers a type system without needing to add extra characters to make types explicitly in your code. That's how TypeScript knows that hello world is a string. You may have written JavaScript in Visual Studio Code and has editor auto-completion. Visual Studio Code uses TypeScript under the hood to make it easy to work with JavaScript. Defining types. You can use widely variety of designing patterns in JavaScript. However, some design patterns make it difficult for types to be inferring automatically. For example, patterns that use dynamic programming. To cover this case exactly, patterns that use dynamic programming, okay, anytime that you need to, for example, anytime that you use things like map that is relying on a dynamic behavior here, as long as you define is the shape of that, or even objects, right? And this is quite interesting. Patterns that use dynamic programming here. Let's going to now ask Claude here about this. You can say, hey Claude, what are What are patterns that use dynamic programming, uh, or what is a sentence, right? What is the sentence? Describe. Okay, what is a sentence describing? Sorry, my bad. Describing from Typescript here, say Typescript land here from here. Jail. Okay. If you need to go with research, go for it. Oh, he's fetching those research. Oh, it is, my friend. It is on the docs, on Typescript for JavaScript programming, right? Sorry, it's here. Okay, it's gonna fetch that resource as an HTML found. However, some design patterns is difficult to type by inferring automatically. For context, it should be between two related. The point made is that you can use a wide variety of design patterns in JavaScript, but since some of them, like one used in dynamic programming, make automatic type inference difficult. What are those patterns that use dynamic programming? Okay, and what is where can I look at it, and what is dynamic programming? Okay, a couple questions that I think that's is going to unveil the mystery around this, right? The term dynamic programming has two completely unrelated meanings. The algorithm techniques for dynamic programming from Bellman, breaking a problem into overlapping subproblems or catching results like memoizing Fibonacci or shortest path algorithm. This is what most programmers mean by the term today. Dynamic programming in the sense of is dynamically shaping object at runtime. The Typescript docs mean the second thing, not the algorithm one. The phrasing is a bit loose-dated, but in context is about patterns where object shape isn't statically known, so the compiler can infer types to that. So what are the patterns? So what patterns are referring to? Any time that change the shape of objects at runtime is considered as dynamic programming by Typescript. Interesting. So for example, dynamically adding properties to an object, returning objects whose shapes depend on runtime arguments, mixing dynamic object composition, meta programming with proxies, where properties access is intercepted and handled dynamically, so there is literally no fixed property list to infer, and deserialize deserializing arbitrary data, JSON.parse, which returns any because of the shape can be known at compile time. And this is very, very interesting here. Very, very interesting. So in this case, that's very, very revealing here. So now that I'm looking at this, okay, that the term Typescript here, all right, so the term Typescript here, all right, or the term dynamic programming is not the algorithm, the destruct algorithm, is that the shape of the objects. Anything that is not guaranteed, doesn't allow you to understand the shape of the objects at compile time. So for example, if you modify is the shape of these objects via adding a property at runtime, or using now a map, which is part of the index collections, or using metaprogramming, or parsing a JSON at compile time, in all those cases, it is very hard for TypeScript to know that, and it makes a ton of sense. So to cover those cases, TypeScript support an extension of the JavaScript language which offers place for you to tell TypeScript what type should be. For example, to create an object with an inferred type, which includes name, string, and ID, you can write this, and then you can explicitly define the types here, which is interface user, and the define is that. So you can use the declare that JavaScript object conform to the shape of your new user, of your new interface, by using syntax like type after the variable declaration. If you provide an object that doesn't match the interface you have provided, TypeScript will warn you here. It's like, hey, this is something that I don't know, right? Do you want me to update? And so on and so forth. So since JavaScript support classes and object-oriented programming, as well as functional programming, because at the end of the day, JavaScript is a multi-programming language. It's a general purpose programming language, right? You can write your programs in a procedural way, or as it's just a procedural way, or a functional way, or as an object-oriented programming. So those TypeScript, you can use an interface declaration with class, which is this interface like this, name and ID. And the same for this class, user account. So the question will be is that what is the difference between now the interface and the class? Again, something that go beyond the scope of today's video. But yeah, right? So with the class is that you can create now those instances of the language, right? This is what you have to, in my case, I have to look at JavaScript essentials, or the typings here. You can use interface to annotate parameters and return value to functions as well. So this is part of the describing the types of function signatures, right? There is already a small set of primitive type available in JavaScript: boolean, big int, null, number, string, symbol, and undefined, which you can use in interface. So TypeScript extend the list with a few more, such as any, allow anything, unknown. So TypeScript extend the list of with a few more. Any, you can do it, this value can be anything. Unknown, ensure someone using this type declare what type is. The other is never. It is not possible that this type could happen. And void, a function which returns undefined or has no return value. And it's interesting because here, when you're starting to read the docs, is describing what the things is, right? You will see that there are two syntaxes for building types: interface and type. You should prefer interface. Use type when you need the specific features here. Interesting. So you should prefer, again, there is a debate here with TypeScript in the community. Hey, you should go interface or type. The docs say that you should prefer interface unless you have a specific need in the feature using types. So composing types. So with TypeScript, you can create complex type by combining simple ones. Union is one of them, right? So this particular feature is when you need that this particular variable have all these possible variables here. So that makes a ton of sense. So in that case is, hey, for configurations, right? This is the environment, this is the literal variables that it can be. So for configuration things like dev, testing, or productions, this is a very useful features of the type. Okay. So there also is a common thing here that say, hey, think of types much like how you create variables with the same name in different scope, right? Think of type like variables, right? So yeah. So this is one of the things that you can do with types. So composing different types with unions here. Unions provide a way to handle different types too. For example, you may have a function that takes an array or a string, right? For example here. And to learn the type of variables, use the type of operator that you can use. And in this case, array.is array. For example, you can make functions return different values depending on whether it's passed of a string or an array. For example, like this. Hey, if this is a string, I will allow you to return now an array. But if this is a string, just a string, right? And the other is genetics. Genetics provide a variable. Genetics provide variables to types. Okay, variables to types. A common example is an array. A variables to type. So what is the variable for this type? An array without genetics could contain anything. An array with genetic can describe the values that array contains. So you have now this, right? And here you might want to describe is the value or the genetics provide variables to types. Okay. So this can be is the variable of this type. And you can declare your own types that use genetics. So you'd say, hey, this is the variable for this type. Okay. Variables for two types. Interesting. Interesting. Okay. Makes sense. This is a variable for types. The genetics here. And this line is a shortcut to tell Typescript there is a constant called backpack. Okay? And not to worry about where it came from, right? So declare const backpack like this, where the type that it can accept as a variable is a string. Okay? Object is a string because we declare this above as the variable part of the backpack, as it is, right? And since the backpack variable is a string, you can pass a numbers to add functions as it is. That's right. And then you have the structural type system, right? One of the TypeScript core principles is that TypeScript checking focus on the shape that value have. This is something called duck typing. So one of the TypeScript core principles is that type checking focus on the shape of values. This is something called duck typing or structural typing. This structural typing or duck typing is it walks like a duck. And I really love to use this analogy here. If this walks like a dog, bark as a dog, it is a dog. If this bark like a dog, walk like a dog, it is a dog or it is a terrier. You may wonder what the French toad is a terrier. Welcome, my friend. Welcome. This is a Therian, right? Somebody who identifies himself as an animal, right? So in any case, it's an structural type system. If two objects has the same shape, they are considered to be the same type, right? If two objects has the same shape, they're considered the same type as it is, right? So point x variable is never declared to be a point type. However, Typescript compares the shape of point in type check. They have the same shape, so the code pass. The shape matching only requires a subset of object fields to match here. There is no difference between how class and object conforms to shape. Virtual points, and then you got it here, a new point, right? There is no difference between how classes and object conform to shapes. So if the object or class has all the required property, Typescript will say they match, regardless of the implementation detail. So this is a very interesting, because then you can start to read about the handbook. But this actually now, by looking at this spec and describing is this, we can now have a huge sense of what this all about, right? In terms of what the JavaScript is, what is the Typescript is at the end of the day, that guarantees a set of rules at what the possible types can this value be, all right? Is not going to modify the runtime behavior, because it's not adding anything in the final output at the build step or after the compilation, right? But what it does is to remove the type when the code is compiled. So now that's something that can be understood by these embedded applications, like the browser or the server, like Node.js. And that makes a ton of sense. So now that I understand the terms of embedding here. Holy moly. Okay, and here, well, briefly to describe is, how does it make sense for JavaScript programmers? Well, types will be inferred most of the time by the value, and sometimes when you have to rely on patterns that modify is the shape of these types, right, or of these objects, you can use now interface, classes, or types. It is preferred to use interface unless you have a specific need for going with types. And on the types, you can now use this to define multiple types that this value can be, compose several of them using union on that. You can also verify what is the possible value that it can be by using is the type of. You can also assign a type to a variable that you can say, hey, this is the value that I want you to use, right? For that case. And the other is a structural type system. So this is dog typing here. And in the structural type system, if two objects has the same shape, right, they are considered to be the same type. So the point variable is never declared to the point type, right? However, Typescript compares the shape of the point as a value here to the shape of the point here, like this, right? In the type check, and they have the same shape, so the code pass. So if you at runtime are passing now this shape, and when I'm going to evaluate this function declaration, you receive that the same shape. So now, well, this is the same shape, right? I'm not gonna complain about that. The shape matching only requires a subset of object fields to match. So if you have a point 3, you have the rectangle, right? And you have now the color here, and then you want to pass now is the color down here. It's saying no. I cannot assign X to the point to this type here. And this is when you're starting to make sense of how you can read about this. The argument of type X, so what I'm receiving here in this function is not assignable to this type point. Or in other words, is the type point and X and C, right? So that'll be all for this video. Take care. Bye-bye.